So here we have some tougher rhombus examples. The first one is a multiple choice. It says parallelogram HIJK. So we already know it's a parallelogram. With diagonals, HJ and IK must be a rhombus if which of the following is true. Choice 1 is that HJ is congruent to IK. Those are the diagonals. Congruent diagonals, that's a rectangle thing. That's not a rhombus thing. So that's not our answer. Angle HIJ is 90 degrees. That is also a rectangle thing, not a rhombus thing. HI is congruent to JK and HK is congruent to JI. That is a parallelogram thing. We already know it's a parallelogram. So that is not going to help us. So by process of elimination, we already know that it's choice 4. And the reason it's choice 4 is HJ perpendicular to IK. That's my diagonals. And perpendicular diagonals, that's a rhombus thing. All right, algebra practice. A rhombus has diagonals that are 18 inches and 30 inches. So I'm going to sketch my rhombus here. I'm going to shape with 4 equal sides. Sketch in the diagonals. Now I know that the diagonals are 18 and 30, but because it is a parallelogram, the diagonals bisect each other. So that 18 is split up 9 and 9. That 30 is split up 15 and 15. They want the perimeter of the rhombus. Perimeter means I have to get the length of this side or any of the sides. All of them are the same. I mentioned in the first page of the notes, in a rhombus, hidden thing, 4 right triangles. Right triangles have right angles have the Pythagorean theorem. So to solve this question, I could do 9 squared plus 15 squared is c squared. If we solve for c, that's going to give me one side of that rhombus. And then the perimeter is going to be 4 times c. I'm not going to go through all the steps. The second algebraic example, rhombus PQRS is shown. T is on PQ such that RT is perpendicular to PQ. So we got some right angles there, 90 degrees. Diagonal QS. Well, the diagonal of a rhombus bisects the angles. So these are equal. Angle P is 118. We have to get angle TWQ. So we're looking for this guy right here. There are lots of different ways to get this angle. Really, you could focus on different triangles, linear pairs, vertical angles, take your pick. I'm going to focus on this triangle right here. They didn't give us the 118 for nothing. They gave us the 118 because this is a parallelogram. And in a parallelogram, consecutive angles are supplementary. P and Q are supplementary. So if I take 180 minus 118, I get 62 degrees. That is the measure of angle Q. I'm going to cut that in half, and I get 31 degrees. That tells me that each of the angles at Q have to measure 31 degrees. So I've got 31 and 31 here. Now we're basically there because we have a right triangle. We know that one angle is 90. We know the other angle is 31. That gives us 121 degrees. 180 degrees in a triangle minus 121 that we have already. And we have 59 degrees for angle TWQ. I went through it quickly and walked you through it, but you are going to have to do some thinking. Look for linear pairs, look for triangles, look for right angles, look for vertical angles. Don't forget those properties of parallelogram. They can hide things in diagrams that you just overlook. So be careful when you're dealing with these. I think that is our last question, right? Awesome. Time for some proofs.